Hello, algebra students. Today we are continuing our exploration of graphing, and remember, I'm trying to relate it to something you know. These equations kind of look like y equals mx plus b. Not exactly, but they kind of look like it. So today we're going to explore what's going to happen when we have a number in front of the absolute value like this. And you might have guessed that's going to be kind of like the slope, because when we did these, what number was in front of the absolute value? Well, there wasn't one, but couldn't we assume a 1 was there? And remember our slopes were like 1 over 1 and 1 over negative 1. So let's get on to it. Okay, this black one here, number 1. I know that my center, my vertex, is going to happen at the point 1, negative 4, right? So I'm going to go 1, 1, 2, 3, 4. Now, I'm still going to get the V shape, but because my slope is going to be a, oops, silly mistake there. It's going to be like 2 over 1. I'm going to rise 2, run 1. So I'm going to rise 2, run 1, rise 2, run 1. Now, to get the other half, it's the same thing. I'm just going to rise 2, but go back 1. And you might notice here that my V got an awful lot skinnier. Yeah, my V got skinnier. So let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, let's see. There we go, something like that. Make it a little bit thinner. And then, of course, I have to do the other side as well. And there we go. So we've got the same V shape, but that 2 being in front caused everything to climb more, uh, rise 2 instead of just rising 1. What do you think will happen with a negative there? Well, let's see. Let's find the vertex first of all. I know the vertex is going to be at negative 5, negative 1. 3, 4, 5, negative 1. Well, if I did a slope of negative 3 over 1, it's going to go down 3. 1, 2, 3, 1. 1, 2, 3, 1. Right? And then, of course, I do the same thing, but I go back 1. 1, 2, 3, back. Okay. And so you see my V actually turned upside down in that case. So I get something like this and something like that. So a negative in front turns my V upside down. Okay, let's try the green one. Let's see what's going to happen when we have a fraction in front of there. You might be able to guess. Well, the vertex is going to be at negative 2, negative 3. 2, 1, 2, 3. All right. And so we're going to rise 1, run 1, 2, 3, 4. And rise 1, go back 1, 2, 3, 4. So you see, I'm going to get a real wide V. This stuff should be pretty simple. And there you go. All right. So when I had a 1/4, the V got really open. When I had a 2, the V got skinnier. Or a 3, it got skinnier. Okay, now if a negative 2/3, it's going to get wider, and it's also going to be upside down, right? So the vertex is going to be at 6, 1. 1, 2, 3, 4, 5, 6, 1. And then I'm going to go down 1, 2, and over 1, 2, 3. And 1, 2, 3. Down 2, 1, 2, 3. 1, 2, 1, 2, 3. Something like that. Gonna make it thinner. And so we're going to get something like that. All right, so let's just recap what we know about graphing absolute value, and then we can call the video an end. Okay, when we have y equals, say 4 times the quantity of, times the absolute value of x minus 2 plus 5. Okay, um, this moves the vertex 2 to the right. This one moves the vertex up 5. So in this problem, the vertex is at 2, 5. Okay, now this is my slope, and I'll use 4 over 1. And to the left of the vertex, I will use 4 over negative 1. If the slope is negative, the V opens downward. Okay, whole number slopes make the V skinnier, and fraction less than 1, of course, fraction slopes make the V wider because you're running more than you're rising. Okay? All right, that's it for the video. We'll get some practice with this in class. Don't forget, on Thursday, we're going to have a quiz over this, all the things we've done with absolute value. All right, Mr. Lawrence signing off. Have a good night, everybody.